All right, let's take the IMDb database. So I just gotta find one. IMDb here, random forest IMDb. I'm gonna duplicate that one. And here this will be a test for us because of the hyperparameter tuning. I tried with grid and random search and it took forever. I couldn't get it done within a reasonable time frame. So let's see here what we can do. So I'm gonna call this GBM IMDb, and the first thing that I want to do is run this thing to make sure that the code is running well. Now this will take a little bit longer because this is a huge data set. Now remember, this has 50,000 movie reviews. So we're done here and you see an accuracy of 84.5%. Now let's see if we can beat this with gradient boosting. So here you see we start the random forest classifier. And we can delete this block of code. Yeah. And of course, the first thing that we do, we're gonna install that Bayesian optimization library or model. So here we go. And then we will add the block of code that will import the necessary libraries. So here we go. This is the same as in the previous exercises. And basically what we can do is try to fit the model without doing parameter optimization. So it's not so difficult. We add just 2 lines of code. We create a model not tuned. And then we fit the model. So this might take a little bit of time. All right, we're done now. So let's now make a prediction. And we just copy this code in there and see where we end up. 84.5%. Actually not that bad. We've done no parameter tuning. So let's comment this out, that one. And let's do a session of parameter tuning. So let's add the code for parameter tuning. So these have not changed anything on the boundaries. Yeah, call it model tuning. All this is fine. We have a big X train. Let's see if we have this here. No, you see here we have a small x. So I will need to change that into a small x. And all the rest is the same. Let's put 5 iterations here. And let's run this. Now this is gonna take a while. This may run for a few hours. All right, we're done. And here you see that the system has given us some numbers in terms of parameters. So let's fill these in. Call sample by 3.7 is correct. Here is the learning rate. Let's round it to 2. Gamma 0. Maximum depth is 10. Let's round it to 10. Minimum child weight, let's round it to 5. And then the number of rounds is 138. Then subsample is 0.6. So we're good to go. I ran that. So I fit the model. And I made a prediction. And here you see that we're quite good. It's 85.9. And that's actually the best score of all classifiers up to now. Logistic regression was at 85.8, so very close. All right, let's compare the results of the coding session. For Pima Indians, it's 74. It's definitely not the best score. K-nearest neighbors by far gives us the best score, albeit that 77.9 is not really a great score. Yeah? there's probably a lot of things that we can do to improve that score. I just need to tell you that when I use grid search, and we could do it for this data set, yeah, then the result was 75.3, which is slightly better. Yeah. IMDb, yeah, you see with SVM we were not able to get a score because it took forever. Now we get a score of 85.9, and with 85.9, Gradient Booster is actually the winner. Slightly better than logistic regression. We did not touch Reuters because this is a multi-class big data set and we couldn't get through it. Okay, but breast cancer we did, and we have 98.2. So clearly bagging, random forest and boosting give the best score in terms of breast cancer. Okay, what's next? Well, next session we will discuss recommender systems. Yeah, it's something totally different. So to that list here, we're gonna add neural networks. Yeah, neural nets, deep learning, and we will see if we can improve any of these scores. So this is it for lesson 11. Hope you understand what decision trees are and how to work with them. See you next time.